Hey guys, welcome back to Total Tech. Today we're going to do a little fun side project that I've kind of been working on with some friends. One of them, he's a machine learning engineer, I guess, or AI engineer at a company that is owned by Microsoft. We'll just leave it at that. But we were kind of talking about, okay, is there a way to maybe predict winners and losers in things like sports? Because obviously this is a big area where people are always interested in, and one of the things, at least in the United States, that people really enjoy is the NFL. So we kind of got together. He did a lot of work on getting the data for actually getting all these NFL stats. So I'm going to show you here how I kind of did a really brief analysis, machine learning analysis, and came to some interesting results and conclusions on how to predict winners and losers for an NFL game, for example. So right here I have some data that I downloaded, and he was able to download this data for going all the way back to 2005, or individual stats for games in the NFL. So if we open this up, let's open this with Notepad++, for example. You can see here this is a bunch of stats for aways, downs, wins, yards. Everything's for all the teams here. So we have like Oakland Raiders, New York Jets, etc. And the question is, how do we do machine learning on this data set? So really quickly, I'm going to show you the script that I kind of already made here, and I'll walk you through it step by step to see what we did. So if you've seen our previous videos, I relied pretty heavily on this package called H2O. So here is just a couple steps to really do some machine learning on H2O. So we're going to uninstall previous versions of H2O to make sure we have a clean install, and then we're going to get to the other packages that H2O relies on. We're going to install the latest version of H2O, and then we're going to call the H2O library and two other libraries called ggplot2 and dplyr. So I'm going to go ahead and install these two libraries separately first. So ggplot2, going to install really fast. Make sure that's installed. You restart. Yeah. Do you want to restart prior to install? Yeah, sure. Okay. We're going to install that one. Make sure that ggplot2 is there. Okay. And then we're also going to install dplyr. And dplyr is just a library that helps you do some data transformations in R. It's really useful for working with some more cumbersome data objects, and I'll show you later how we're using it. So here I'm going to also run this to load all the libraries. I've already pre-installed H2O, so if you run these commands, which I have on my GitHub, you can check it out. It'll install the latest version of H2O in your system. So I'm going to run a local cluster, so we're going to initiate a cluster here. And this cluster, if you remember, is going to spin up a Java-based H2O machine learning environment. And we can actually go to localhost here. So if I go to open up a browser and go to localhost 54321, we can actually see the cluster here, and this is our machine learning cluster. So we're not going to actually do anything in this UI. You can do stuff through this if you want. It's a little bit easier for some people, but right here I'm going to go and create a common path variable, which is just a path for where I have this data downloaded. So in this data, you can see that I have NFL match stats, and inside there's a folder for each year, and then in each folder there's a series of CSV files. So what I'm going to do is I want to read all these files in at once, and instead of like doing read.csv for every single file and every single path, we're just going to put the common path here, and we're going to use this list.files, and it takes in a couple parameters. This is the path to the common directory, and we're looking for any files that end with .csv, and this is a regex pattern, and basically it's just a regular expression that's saying we're looking for any file that ends with .csv, and this is recursive. We're going to set recursive to true because we want to do all subdirectories. So if you remember, NFL stats is the first folder, but then there's a folder for each year, and then there's the file. So we want recursive, and then we want full names true. That's the full path for the file. So we're going to do that, and we're going to read this in. So this is the list of files to read. I've created an object for this, and then I'm going to do data lst lapply for read.csv. So basically this is an lapply, list apply for the list of files that I've created. So if I run files to read and run it, you'll see that this is just a list of all the actual file paths. So we're creating a list of a bunch of file paths, and then we're going to do list apply. So for every file path, we're going to do a read.csv and then put it into a data.lst object. So if I run that, you'll see that now I have a large list right here on the right of data frames, and each data frame has all the data, but this is actually a list of data frames. Now that's not exactly what we want. So what I wanted to do is combine all this data into a single data frame. So I'm going to do this here. And this is going to bind rows. And in order to have this bind rows function, you need the dplyr library. So we're going to bind rows for this data list, and then we're going to bind it by the column label, and then we're going to put it in a new object called data. So now we have a single data frame here of every single game with every single stat for the NFL since 2005 that we could get our hands on. So if you look here, we can have things like the attendance, the away first downs, the away fourth down attempts, away fumbles, interceptions, lost, net pass yards. We have the score, penalties, stuff for this, yards lost from sacks, duration of the game, and we have all the home stats also. And then if we go to the next set of stuff, we have even interesting things like what stadium it was in, what the roof was, what the over-under in Vegas was. Now, if that is useful, maybe, I don't know. The surface that they're playing on, is it grass, is it turf, is it, and the weather. We have stuff like the weather too. So we're going to see what we can do with this and do some machine learning. So what I'm going to do here is I'm going to actually, instead of, I'm going to pick a few columns to keep. So I'm looking at the data here. I kind of want to know who is the winner. So I think there's a column called winner, I believe. Winner. Oh, okay, so that searches by column. So let's filter by, let's see, let's just go through here. So I think we're going to keep things like I'm going to keep fumbles, interceptions, and sacks, I think. Yeah. I'm going to take fumbles, interceptions, and time sacked. And then I'm also going to take that for the home team. And then I'm going to find out the actual winner, if it's away or home. So I believe so there's a column here that's winner, and it tells you if the home team wins or the away team wins. So basically my goal here is to ask a very simple question. Can we predict if the home team or the away team wins based only on the number of interceptions, fumbles, and sacks that each team has? And if we can, then we can kind of have a pretty good prediction of whether or not those teams are actually, that kind of criteria is enough to predict a winner or a loser. So what I'm going to do is I'm going to run this keeps, and I'm going to keep the data for just those columns. So that's what these two commands did. And you can see here now we have the winner, and then we have the away fumbles, the home fumbles, the away interceptions, home interceptions, the away's time sacked, and the home time sacked. And based on that, I'm going to try to see if we can create a machine learning model to predict winners and losers. So I'm going to do a random split of 80% for our training data and 20% for my validation data. I split them over. And this is going to be splitting these into two data sets. So now I have my training data set and now I have my validation data set. I'm going to take the winner column as factors because it's a text column, so this has to be taken as a factor. And then I'm going to import this into the cluster for H2O. And then we're going to predict by the winner column, so that's our response column. And then our predictors will be all the other columns that are not response. So now what I'm going to do is I'm going to run a model for H2O.ml. I'm going to give it a max runtime of 60 seconds. And as that's running, we're basically predicting whether or not the home team wins or the away team wins based only on these data sets. And from there we can see how well our model does and see if we can actually predict pretty well how to which team will win or lose. And that's going to be kind of the main question here. So there's a lot of things you could do with this data here. I could predict things like, is there a particular team throughout the season that is going to win more often based on certain stats? Does the weather affect which team wins or loses? Does the stadium affect which team wins or loses? Like, there's a lot of questions we could ask, but I'm just keeping it very simple as an example of how to do machine learning on real-world data. So this data is real-world data. So my previous videos, when I was giving kind of the introduction to H2O, the data that we was using is like kind of an iris data set, but it's kind of like a well-known, well-trained data set that's, I think it might be real-world, but it's pretty like small and simple. This is a little bit more complicated because now we're taking data over multiple years, over multiple teams and multiple games played. and this is all from real-world stats. So this is an actual example of real-world machine learning. So it looks like our training finished. I'm going to look at the leader, and I'm going to look at the AUC to see how well we did. Oh wow, okay, so our AUC is actually 0.86, which is pretty good. That means that about 86% of the time, I would say, we have some pretty good examples, or some pretty good, I guess, predictions here. And this is on the validation stuff. So let's look at the explainability plots to see what variables are actually the most contributing factors to whether or not we can predict whether a away or home team wins or loses. Okay, so I'm going to create an ACO explain, create some plots. So this is the model correlation. So it looks like GBM models, GBM usually does the best, but okay, variable importance. This is very interesting. So based on this, for deep learning models, they didn't perform as well, but you can see here for the general linear model and then all the gradient boosted machine models that the away interceptions and the home interceptions seems to be the most important thing in determining whether or not a team wins or loses. So I'm going to take this and interpret this as most likely if a team gets more interceptions, they are going to win the game. If a team gets intercepted on, they are more likely to lose the game. And it seems like sacks and fumbles may have some contributing factor, but not nearly as much as interceptions. So that's kind of what I'm initially... So this is another example. This is for the general linear model, so that says the same thing. And it seems that that is the most... yeah, that seems to be the most important variable, it seems. And then here you can see the stat plot for the same thing, and it seems that based on home interceptions and away interceptions, most of the models and most of the predictions are based on that. Although home time sacked can really make a difference too, it seems. So it seems that being sacked at home is a bigger contributing factor than an away sack, which it makes sense because if you get sacked in your own stadium, there is a sense of like, oh crap, we're in our home stadium and we got sacked. So that kind of makes sense. There seems to be a slight helpful information for home fumbles and home sacks. So those are some interesting things that we just pulled out of this machine learning model. This is done, very much on the fly. And if we see here, we can look at the let's list the models here. So let's list the model. Let's list one of the gradient machine models. Yeah, so log loss here, AUC 0, this one's 0.87, so I mean, that's pretty good. So we can see here on training metrics, precision away, 81% correct, 78 for home recall, 87, 69, okay, and then on the validation, not as good, 76, 75. That's kind of what we would expect. The validation is never going to be as good as the training, but it's still pretty good. So the AUC is overall pretty decent. So that's some real world model training, and that's how you guys can do some machine learning. In terms of how to get this data, I am not the one who actually got all this data, so there are a lot of repositories for pulling this information. You can download your own data, real data sets, and do this type of machine learning model. And this is really quickly set up, and we did this in about 15-20 minutes. And I can plot the AUC, so I think I can plot the actual AUC here in R2. Let's see. Oh, partial dependence plot, okay. Quit. Then I'm going to run this one, plot here. Yeah, so this is our AUC plot for our model performance for this model. So yeah, I hope you guys like this. If you do, be sure to share it with your friends. Please put any questions and comments in below. I know I went through a lot of things and I went through it quickly, but just for the sake of time and stuff, I just wanted to show you guys how you can do this on real world data. So please like and subscribe. Thank you and have a good day.